Alright, this is question 2 from the 2011 test. This is dealing with a full water tank that's going to start draining water out at a certain rate. They've given us the rate. The rate is piecewise, simply meaning the two different parts are kind of losing water at a different rate. Maybe they opened the valve more or closed it or something. Alright, part A. Is R continuous at 5? Show the work that leads to your answer. So part A, simply going to be finding out continuity is if the limit equals the output. So I need to find the limit as t approaches 5 from the negative. I need to find the limit as t approaches 5 from the positive. And then I need to find what is r of 5. If all three match, then it's continuous. So I'm going to use my calculator to do that. I've already put the equations in, so I'm just going to go to table, and now I can just type in a 5, and if I typed it in right, I am not continuous. So r of t from the left looks like 375, which should be liters per hour, and then this is 367.88 liters per hour. At time 5, that'd get plugged into the top equation, so that would be 375 liters per hour. And so, is R continuous? I would say no, because the limit as x approaches 5 of r of t does not exist. Okay, I kind of was expecting a yes answer, but unless again I typed my equation in wrong, which I've been known to do. And maybe it's worth stopping for a second and double checking. 1000 e to the negative 0.2 x, 600x divided by x plus 3. Okay, we're good. Find the average rate at which the water is draining from 0 to 8. So this is the rate. It's asking for the average rate, so I'm adding up the rates. So this is an integral question. And ultimately I'm going to add up all the rates and divide by 8. So I'm going to do that as one big sum. So let's add up the first rates from 0 to 5. 600 t over t plus 3 plus 5, and we're only going to 8 of 1000 e to the negative 0.2 t dt. Alright, so calculator's going to do the work. So, math 9, variables, y1, comma, 0 to 5. Oops. Got an error someplace. Oh, I forgot my x. Comma x, 0, comma 5. So I'm going to get 1/8 of 1, 2, 3, 4, 5, 073 plus, and I'm going to do it again. Easier just to type it in for this one instead of copy. So I've got the integral of the second one, so that's under y2, comma x, comma 5, 8, and that's 829.9146. Add them together. 073. So I got 1/8 of 2064.4219. So I get an average of 258.0527 liters per hour. Find the average rate between that. Don't explain it. Always put units. Part C. Find r prime of 3. So I'm just going to take the derivative of r at 3. And 3 is in this range, so I'm going to use this equation. So I just need to take the derivative of that and evaluate it at 3. So let's tell them what I'm doing. R prime of 3 equals the derivative of 600 is probably unnecessary, but doesn't hurt to write it down. Evaluate at 3. Actually, I really don't like the way I've written this. It should be really the... Let's do this. Now I'm just regretting this whole thing. I've come this far. So really what I'm saying is the derivative of that with respect to t at time 3. Okay. Math 8 for derivative. That's in y1, comma x, comma 3, 50. Mine gave a 50 and then a whole bunch of zeros and a 139 at the end, so to 3 decimal places I'm just going to put 50 with 3 zeros. Now what does it mean? Well, that's the liters per hour per hour. So I found the rate of change of the rate of change. So what do we want to say here? At time equals 3 hours, the rate at which the water is draining from the tank is increasing at 50 liters per hour every hour, or script per hour, 50 liters per hour per hour. Probably a better way to say that, but I think it gets the job done. Part D, write but do not solve an equation involving an integral to find the time A when the amount of water in the tank is 9,000 liters. Okay, so we got to go back and remember we started with 12,000 liters, and then we're going to these numbers are all being reported as positives, right? I plug in a positive 5, I get a positive rate, but that's the rate that it's leaving. So I'm going to say 12,000 minus the amount of water from 0 to the time A of r of t dt. So what does this say? Add up all the rates of change. That'll tell you how much has changed. We're going to take that number and subtract it from the initial amount, and I want that to equal 9,000. And that should give me my answer. Let's quickly check our score. Let's see, it's hidden behind here. And we have a little guest. Cora has arrived in the room. Hi, Cora. Hello, can you count? Yeah. Okay. Alright, let's check our answers real quick. 375 and 367. That looks good. Part B, 258.052. That looks good. And Cora's looking at me like I'm crazy. And you went up, Cora? Okay. Part C, 50. Looks like we got that right. And too far. Part D looks good. All right, we'll pick it up on video 3 on the next one.